locally nonetheless in case something doesn't work. All right. Welcome everyone to
One second, still starting.
Oh yeah, but yeah.
Okay.
All right. So welcome everyone to this week's IPLD meeting. It's January the 7th in 2019. It's the bi-weekly sync from the IPLD working group. And let's see what we have on the crypt pad. I'll paste the URL in case someone isn't on the crypt pad yet. Oh, we need a note taker. Any volunteers for note taking? This week's is probably pretty easy because there isn't that much, I guess. So, any volunteers? If not, I can do it, but then someone else has to lead the meeting because doing both is really not that ideal.
In that case, I'm happy to volunteer.
Okay. So, do you want to take the meeting or take the notes?
I can take the notes. You made the offer very compelling.
All right. Thank you. So this the crypt pad I posted in the chat. Thanks a lot. All right. So so please put your name on the attendees list in the crypt pad if you are attending. All right. Other than that, we go through what we've worked on the past 2 weeks. So I'll start with Eric. Please give us an update.
Oh, yeah. Hello. So, like most of us, vacation, but it was a very productive vacation. CCC had a lot of great brain food conversations. So one of the things I spent a lot of time thinking about was open versus closed enumerations and getting in arguments with people about that. So I'm trying to reduce what I learned into some notes about ways we can refine open versus closed dichotomies in enumerated types into like more productive, like what is a behavioral tree for what we want to do when we encounter problems with a closed type. So yeah, I've been trying to do some writing on that and getting something ready to share. I'm not sure if it's there yet, but maybe soon. And so going forward, I'm going to try to finish that up, get something ready to share, and then poking more implementation on the Go side. That's about it. David, do you have a question?
Yeah, I have a question, if I may. So by the way, awesome. I saw the CCC pictures. It looked awesome. I'm really looking forward to see the notes from all the conversations. My question is, I believe in my apologies if I missed to read something, but I'm not sure if I understand how Go IPLD Prime kind of builds, or sorry, my vocabulary is all screwed up today. I'm not sure if I understand how Go IPLD Prime fits in the IPLD puzzle that we've been thinking about graph sync and the IPLD APIs and the revamped IPLD API for Go IPFS, etc. Can you give me just a quick description of what Go IPLD Prime is?
It's the revamp.
It's the whole revamp?
Yeah, whole thing.
Okay. So from the core API to the HTTP part, which
no, it's a
the HTTP part.
It's a Go library for working with IPLD objects that is more IPLD specific and less like half protobuf, half IPLD.
Got it.
So like it provides, as far as I can tell, efficient APIs for streaming objects and traversing through objects and that kind of stuff, and deserializing them, where the current APIs are somewhat painful to use.
Yeah, spiritually, it's going the exact same place. Practically, it's a new repo so that I can write new code without friction with existing projects, depending on the current interfaces, when in some cases the current interfaces are wrong and several things need to be adjusted all at once. So like all sorts of things that are well documented in the existing repos, like links have these 2 other pieces of metadata that nobody ever uses and are unset in practice in all implementations, just skipping those things in this implementation. So at some point, yes, to the question in chat, it will replace the current Go IPLD implementations, but it's gonna be a while.
Got it. My specific question on the does it touch the HTTP part is because the JS side keeps like struggling with like just dealing with IPLD when using Go IPFS, the daemon, because like the HTTP API right now in the way it works like serializes everything to JSON, and so it has been a struggle to make the client library JS IPFS API to work with the VEG API of Go IPFS because of that. To the point where we have to use the block API and deserialize things on the client side and do the resolve of the paths on the client side in order to make it work, because we cannot ask Go directly. Otherwise, Go will mess up with the types by serializing everything to JSON. And so, cool. Okay, I understand now it's not touching this part.
Yes.
Yeah. The solution there is still going to be send back the raw data and have it deserialized on the client side, because we can't, like, given an arbitrary object, we can't guarantee that we can like convert it to JSON. But what we should do is at least like enable either pathing to the JSON API or like not like somehow avoid serializing with the DAG API. But that's a tricky question.
Stephen, I thought you had some clever ideas we talked about in London about like making some more details in the data model layer of the spec about how we can explicitly transform things that make sense in CBOR like bytes into a more expansive JSON object in a canonical way.
We can, but like at some point you're always going to have an issue where like there's something you just can't convert in certain formats. So like we should totally make or try to make it possible to convert. But if you want to fully, like basically if you're using this from like an IPLD library, you should serialize and deserialize locally and then get the raw bytes instead of like trying to like convert in formats. But that's just my take on it.
All right. Any further questions? All right. So next is me. I worked on, so I'm still working on the JavaScript side of APIs. I basically, as I haven't heard any bad things about the new API, I just started to implement it to see if it actually works. Looks pretty good so far. I hope to really get it wrapped up in 1 or 2 weeks. We'll see. And then we can start to integrate it properly. And yeah, next, any questions on this? Nope.
I do have a question. Or I have a suggestion. It would be great, like if the update here would say more than just IPLD work, because that has been going for a while and people don't understand like what is the current status. Like you just described it, but like it in written text. The other thing is, why do you think it takes like 2 weeks to finish the base implementation to then go into the integration to the rest of the code base? Like, what is the big chunk of work that on the IPLD module that would take 2 weeks? And is there anything that we can do to help you achieve that sooner? Because like a lot of things are waiting on it.
No, so the big chunk is the integration. So the implementation is done, but and currently basically JS IPFS completely fails. So it could be like an hour of work, or it could be 2 weeks. I don't know. So therefore, I'm saying 2 weeks.
yeah, better said
But
than
I'm
sorry.
confident that it's All right.
Got it.
All right. So I will add it to my notes that so far it looks good. So basically, the Unix FS part works with the new API. And that's promising because that's the huge part of. So that's clearly the biggest user in JS IPFS of IPLD is the Unix FS part, and that already works. So the other part should hopefully be simple. We'll see. All right. Yes. Okay, who's next? I'm still totally confused because I wasn't on time and now I rushed through all the things. I'm sorry for that. So next is Stephen.
Mostly did a lot of review discussion, I believe, past few weeks, and wrote an IPLD constraints document. The next, more of the same, and hopefully deal with fix up all the comments based on, fix the document based on review comments. Yeah, and potentially document some definitions. I'm not sure if I'll find time for that.
All right, next.
David has a question.
Oh, sorry.
I'm using Johnny's crunch technique of like asking questions to every single presentation. Cool. Sorry if I'm being too annoying. Stephen, I noticed like I have on the calendar a graph sync discussion for next week. Is there any prep reading for that discussion so that we are all ready?
Yes, read graph sync proposals A, B, and C.
Yeah.
They're all linked in the meeting invite.
Oh, is it there already?
Yeah, okay. So the 3 things that we're requesting that everyone comes prepared with understanding are linked there.
Got it. You're totally right. I look at I didn't scroll enough. Thank you.
All right, and next one is Aiden.
Hi. Yeah, so in terms of actually doing stuff, just trying to get used to using IPLD. So I switched the stuff I was using to use IPLD instead of using protobufs and move on the right direction. I'm happy to be a Go IPLD prime guinea pig if required, given that it's just like another set of eyes and it doesn't really affect anyone if it breaks. And then I just had a couple of questions, which I don't know, either get people thinking or just get feedback from people who've thought about this more than I have. So I have 2 issues. One is I'm trying to synchronize a set of commits, basically. And in order to be able to do that, you need to have a shared root so that you can actually synchronize and combine the 2 graphs together. And the root might just be a name. But names aren't really things you should be throwing around as commits. So I'm not really sure if anyone has thought much about this or whether, how these types of things work. I have something that does work because I just sort of took a guess, but any feedback would be appreciated. Stephen, you got something? You're muted.
As far as I know, the right way to do this is basically like have parent links and as like have root objects that, or well, sorry, like not a root, like a sort of like a root object that's a commit object that points to previous commit, and that commit points to parent and parent and parent, and they all point to different roots. And then like you would start at like the 2 forked roots, or sorry, 2 forked commits, walk back until you find a common commit, and then try to merge them. Basically, just do what Git does. That's at least what I would do. Is that answering your question, or is that totally?
Not quite, because I guess maybe think of it like this. Every time you start a new Git repo in GitHub, it has like the same empty object in it. Which means that in theory, every repo on GitHub has the same parent.
Not quite. Actually, it doesn't.
But realistically, they don't, right? Because there's like a name that differentiates them.
I don't know how they do that. I don't think they actually have the same empty object. I think when you start, you don't have any commits, and then the first commit like creates the root object.
I mean, I guess, yeah, sure. Similarly, it could be like if you were just committing everyone committed like a blank README with like a to-do in it, right? Then all of those would be the same repo.
Well, they still have like the commit object has like the date, the like other headers, username, stuff like that. I think there may be other random things. I don't know. Brandon seems to know more about this.
Okay, go ahead. Yeah.
Yeah, no, Steven's bang on. Two people committing the same stuff in Git because the commit message itself includes a timestamp. Even if you, the same person, write the exact same commit at different points, instances in time, you'll get different commit hashes, and so they won't be the same. So any Git commit references a root of a tree, which is the actual file hierarchy. That will be the same, and you can use Git's plumbing tools to actually pull out that graph base, which Git does to do comparison work, but there's a separate section that contains sort of the commit information, which will always change. And so when Git tries to resolve, and so that's where the Git naming system comes into place, and that's where you see like refs, and refs are all just pointers to commit hashes. And so as Stephen had been saying, almost all sort of version histories are built by referencing their previous entry. And so when you try to, you can theoretically merge two things that have no common history, but and I think that's sort of what you're getting at with this notion that there isn't, like, there's sort of this theoretical 0 point where there is no commit, and that's sort of like two histories that don't match at all, which is theoretically could be combined, but like doesn't really make the sense in the sense of trying to sync two divergent histories. You would, for it to be a rationally divergent history, you need one common ancestor. And so that's.
So I guess the difference here is we don't have that other random entropy. Like we're probably not going to always like have like dates and stuff like that. I think maybe this is one of the points you tried to make, but I think it would actually make sense to like make like the IPNS key or something like that, like the root object. But like all the branches say like this thing at the bottom is like or like I don't know, not necessarily the IPNS key, but like some policy that describes like how merging should be done and how this object should like behave. That would actually I think be a reasonable route, but.
Yeah, I mean that's sort of what I did for now. Is I used like an IPNS key or something as the origin to just make it operate.
Yeah, so like that actually think is reasonable. Personally, I would have a more complex object like describes, like you could even name it or whatever you want, like somebody to like I don't know, somehow name this thing, and then you put that as the root. It's kind of weird that like the name doesn't point to anything; it's everything that points to the name. But I think it's reasonable.
Yeah. That also gets kind of inefficient because of the way that traversing over those structures work. So you want to keep the names on the other side, but then you run into a
you may also not want
the universe problem.
It doesn't actually have to be a root either. So like you have like basically the bottom one doesn't actually have, or sorry, the bottom entry doesn't have a parent. It just has a null parent. But then every single commit can point to the same like name. And that basically means every single object would like just say like, hey, like I'm a part of this universe, and that guarantees you have uniqueness.
Totally. But it does affect. You get back to whatever. I'm sidetracking things, but you get back to the issue of like then if you change the reference, then you're getting different stuff and you lose comparability a little bit. But
yeah, you need to have a single thing you never change. Basically, it has to be like one description of like it's like an app ID or whatever.
Totally. Yeah. And as long as you're okay with that assumption, like a lot of user experience side of things want to change names, and you absolutely could not change the name. You would need an app ID.
Well, this would be like a shared key or something.
Totally. Sorry. Super sidetracked.
No, this is good. And it moves me a little bit onto the next question I had, which is any thoughts on what happens when we want to sort of break our links? So for example, if I want to squash my previous 100 commits into a single state, I should probably allow like providing both options, like say the link is here if you want to verify it, but like I pinky promise you it's actually this thing too.
Well, yeah,
and you can check both.
So yeah, in that case, like I would have a special squash commit that points to like the logical parent, and then like the squash tree, and then the new state root, so that you could follow either like you could basically follow either path. Does that make sense?
So you just have like a trusted guy make a squash commit that does that for you.
You can. There are other. You have to be careful about that. I don't know the right way of doing that.
Yeah, I was just thinking about that in the context both of checkpoints and also, what happens if you want to, an old hashing algorithm goes bad and you need a new one.
For new hashing algorithms, I think we'll end up like with large tables. Like that's like the end, like the final thing you can do, where basically you have a large trusted table that maps old hashes to new hashes. I hope we never have to get there, but we probably will someday, eventually. We can deal with that later.
Okay. Thanks.
Some quick mentions on compressing stuff into checkpoints. I don't know if you've heard of the Google Trillion project, but they have some really nice short, terse white papers about they're a log-oriented mapping data structure, like a blockchain. And I can't remember the technical term, but they have some good write-ups on ways to do checkpoints with bounded rechecking time. It might be some good reference material.
Do you mind putting the name of that in the document?
Yeah, sure.
Thanks.
I mean, there's always a snark. If you want to spend all day at it.
All right, thanks for letting me eat up a bunch of your time, guys. Appreciate it.
All right, so does anyone else wants to share any updates or has any questions or comments? No, that's great. Then we even stay on time, although I was late. That's great. Then, yeah, we'll see each other again in 2 weeks. And have a good time. See you then. Bye.
Bye-bye.